In this video, I will explain you how you can solve this Pyspark problem statement. So the problem statement is find the average number of Tinder match for each age group using Pyspark code. So you have to find average number of Tinder match or Tinder connection for each age group people using Pyspark code. So if we have a like 23 years old people and he have a 120 connection, and there is another guy which age is 23 and he has 20 connection. So the average Tinder connection will be 120 plus 20 by 2 for this 23 years age group people. The average Tinder match will be 120 120 plus this number of total number of match by total number of people. That's it. For there will be many age group like 23, 24, 25. For every age group we have to find our my Tinder Tinder match connection. So this is the data set. We have this data set. Now we have to find the average number of Tinder match for each age group. Okay, see, this is the user ID. So the first column is user ID, second column is name of the user, third column is the age of the user, and fourth column is number of Tinder match. So this guy called Nog, the user ID of this Nog is 239, the age of this Nog, this guy is 48, that Tinder match is 342. Here you can see this Quark guy, the 241 user ID is 241, and the age of this guy is 48, and the total number of match is 332. Okay, 332 number of Tinder match. So for the age, for the 48 years old age group, we have to find total number of average number of Tinder match, same like 61, 21, 28, 41 age group we have to find. Like there is a many age group is there. For all age group we have to find it. So how we can do that? So we have to use Pyspark code. Okay, we have to write Pyspark code. Let's start how to solve this problem using Pyspark. So this is my tindermatch.py py file. I will write Pyspark code here. So first thing what you have to do, we have to import Spark context. For Pyspark, import Spark context class. Then now I can take this, import from system module. I have to import stdi system input. Let me drink some water. Now after importing Spark context, we have to create that. This is the one class we are importing from this module. So we have to create the object of the class, that is will be our Spark context. Spark context, we are getting the Spark context here. Now you have to pass some parameter here. You have to say local star. It means we are executing this job in our local laptop, and for to execute this job we are saying that you can use all my star, means you can use all the resources, all the core of the CPU to execute this job. So we are telling this to my Spark cluster. Now we are giving some job name. Job name is Tinder match. Now what you have to do, we have to load this data set. Load this data set from my local laptop to my Spark cluster. How we can do this? So for this we have to create an rdd1 equal to sc.text file, then then we have to give the path of the file. We have to give the path of this file. Path will be like this. Tinder data. I think it is right. Tinder data. Tinder data. Tinder data. Dot CSV file. This is the CSV file. This is CSV file. So here I am loading my local file to my Spark cluster. Now I have to do some analyze and some pre-processing so that I can get output. So if you observe this file, here is there is a 4 column. Okay, 1, 2, 3, 4, 5. 4 column. 1, 2, 3, 4. 4 column. But we want to find the average number of Tinder match for each age group. To solve this problem, we need only 2 column: age and number of Tinder match. Not this four all this name. This is the user ID. This is the name column. This name column and user ID column is not required for our problem statement. So how we can handle this thing? Because we want to pre-process this data so that I can get only 2 column. I not For my case, these 2 column is not required. The name and user ID is not required. So we have to remove those things. So how we can do this using Pyspark. So for this, I will write one function here. So def tinder parser parser. I'll passing on a variable here. Now I am creating one list here. Columns equal to list line dot split. So using this function, I'll try to pass every line, every record in this sorry in this function, and it will try to, and in this format in this function as a string, and then I will splitting this each record splitting this each record. I will pass this each record as a string, then I will try to split this string using comma separator. Okay, I hope you are getting this. I hope you know this, how to split one string. So this will be one string, and this string will contain one record, and I am trying to split it using comma separator. Then it will give me one list. From the list, I only one thing. I have to two things: age and number of connection match, Tinder match. So age is typecasting the age, because we are getting as a string here, so we have to typecast here. So I am accessing two will be the age. If you see this thing, this is the user ID, this is the name, this is the age. So the index will be the 0, 1, 2. So that's why I am accessing this as a 2. So at the index of 2, we will get age. Then I have to get my Tinder connection match. Tinder match. Tinder match will do same thing. I have to do copy this. I have to access this list, and from this list I need third index. Okay, because this is my Tinder match. Index number is 3, 0, 1, 2, 3. Okay, from here I will try to return. From this function will return something. Okay, how we will return our value from this function? How, in which format? Like, we have to think. and then we will return. So we will return this value as a tuple, and it will be tuple of tuple. Okay, so to do this we need one thing. We need also one thing. We need tuple, but we have to manipulate something. So we are passing age comma this tinder match comma 1 y1. Using this one, we'll try to count number of peoples. See, if you want to find the average, there will be total sum, then by the count, like if the 5 people, the total number of connection of the 5 people is 250. To find this average, I have to do 250 by 5 by 5. That's why we are trying using this one. We are trying to maintain the count. Okay, now this function will return list of list. Okay, now come here. So one thing I have to say, this input additive one will hold data like this. So here the data format will be like this. Input after loading the data. So this this data will look like this. Let me copy here and show you practically. What is this 42? Okay, come here. Knock. After loading this, all records will be in a list. Inside the list is a string format. Each record will be in a string format in a list. Then we are created one function here where we have to use this function. For that we have to get another add2 equal to input add1 dot map. Then here I have to create one lambda function here, lambda line. Okay, line variable. So this lambda function will access this string, and it will pass each access this list, and it will pass each string here. Okay, from here it will access this list, and it will pass every element from this list. So now I have to pass this thing inside my this function tinder line. Okay, so after doing this, so we are iterating this list and passing every string inside this tinder parser function, and this map function will return one list. Okay, one tuple, and inside the tuple, so I'll show you what is actually done. add2 dot collect. If I try to show you what is actually this add2 is holding, and try to execute this. So after doing this, what we will do, we'll try to like we have to use reduce by key to add some values. So let wait for some time. When it is executing, we can write our code, but wait for some minute. I think it will execute. See, it is showing some log, then it will come. Wait. Okay, I have to print it. Sorry, I have to print this thing. Print this thing. Copy it. We were getting this tuple of list. So list of tuple. Okay, So now copy these things. I'll put it for our example for reference. So we are getting value here like this. We'll get 48. So we'll get value like this here. So the additive is holding data like this. Inside this additive, the data look like this. Now I'll create another additive 3 equal to additive 2 dot reduce by key. I'll try to add those things. Okay, 345 and 332 and this one and this one. I'll try to add those things. How we can do this? For this we have to create one lambda function here. Then I try to reduce by keys. It will try to match the value. Okay, it will take two same key, so it will take this 48 and so when it is saying there is two same key, it will pass the value this one and this list, this tuple and this tuple inside this x comma y. When saying the x comma y, the x will hold x is holding this tuple, y is holding this tuple. Okay, because key is same here. Now I want to add those things. Okay, how we can add this? For this and for this I have to access this tuple x0 plus y0 comma x1 x1 plus y1. So here we are trying to add this one. X0 means this is x is holding this tuple, so we are accessing the index 0 here, and y is holding this tuple, sorry, y is holding this tuple, and from here we are accessing the 0th index. So this is the adding 332 plus 342, and here we are adding this one and this one. Okay, and after adding this we are creating one list. Okay, we are creating one list. So the data will look like this here. It will look like this. It will look like this. Data will look like this. The list will contain. So let me think how it will be. 370 37 and 377. If I add this thing, and it will value will be 2 here. 2. So RDD 3 will hold data like this. So RDD the data will look like this in RDD 3. So we have this. Now we have to find average. So we are getting. So if we add this, it will be 6, 7, and 5 plus 2, 7, 2, 5 plus 7. It will be 7. So if we add 345 plus 332, it will be like 677. We are also adding this thing and this thing. So it is we are getting like this. So 40 is my age. This is my total number of Tinder match for the 40 years old people group age. The total number of match is 677 677 and 677, and the total like number of people is 2. So this is that's how the data will look like in this IDD3. Now I want to find average. For this we have to divide it. We have to divide it. We have to divide this value with this value. Okay, the total number of match by total number of people for the 48 years old age group people. So how we can do this? So I have to create RDD3 equal to sorry RDD4 equal to RDD3 dot one thing map function. So list lambda, we're writing lambda function here, lambda x comma x colon. Now see when we are saying this x, okay, it will pass these things, okay. From here we want to find, we want output like this, we want to output like this, list 48 comma then average number of connection. What, I don't know, maybe if I be divided by 6 calculator, calculator 677 by 2, 338. So it will be 338. So data should look like this. How we can get the how we can get this? To do this, we have to write, we have to create, we have to write in a such a way that we can find this average. How we can do that? To get this, we are saying x0, x0 means this 48, 48 comma. So map always return tuple. So we are creating tuple here, okay. So now x0, x0 we are accessing, x0 means 48. So we are taking, we are creating one tuple using 48 as a key, 48. Now I have to I have to find average. How we can find average, okay, from here. To access this, what I can do, x1, x1, x0 by x1, x1, x1. Because this is the nested tuple, this is the nested tuple, that's we are using this type of index. I hope you know how to access the nested tuple or nested list. So if you think as a nested list, so to access this thing, what do you have to do? Because this is the inside a list of list, okay. So think, when we are getting x, so we are getting this. So inside this, if you want to access this value, so it is in the index 1. That's why we are writing this x1. So this means it will give us x1, means it will give us this tuple, and from this tuple we are trying to access this thing, this first value. That's why x0. And same here, we are trying to access this here first, and from this tuple we are trying to access this 2, this second index, okay. That's why we are, I mean, second index means 1th index. That's why 1, okay. I think you are getting what I'm saying to say, okay. So after this, so we are trying to divide this thing, so this thing by, so this is holding 677, and this is holding total number of people 2. This is the total number of Tinder connection. That's how we are getting average. Average means total number of average of a specific age group. This is the Tinder average, Tinder connection, Tinder match, average of Tinder match for a specific group of people. Now it is done. What we can do? We can sort it. That's it. So we are getting this. Now I want to sort it in ascending order. So we will get value like this: 48, 338. This is the age, 48 years old people, 40 years 40 years old age group, and this is the average Tinder connection of a 48-year-old age group people. There will multiple age group, like it will be like this, 30 age group 30, the average Tinder connection is 300, okay. Like this it will be there. So we have to sort it. You can sort it, or it depend on you. I want to sort it in the ascending order. So how we can do this? So we have to use sort by function here. Sort by function here, we have to pass a key. According to that key, we want to sort it. So we want to sort it according to our number of Tinder connection. Tinder average, according to one average number of Tinder match. So then we can write one lambda function here, and it will be say x comma x colon x comma 1. So x comma 1 means this lambda function will take this thing. Okay, this lambda function will iterate this list, and this x will pass, this x will pass each each tuple in this lambda function, in this sort. The sort by will, like how the sort will work. So it will take each tuple from here. Then it will try to sort this according to this value, this number of average Tinder match. That's why you are saying x comma 1, because it is inside a tuple. So we are accessing this index, one's index. Now we can print our result. Result equal to rdd 4 dot collect. So this reduce by key map, this thing are what, this thing are transformation, and we are doing action, collect each action. We are doing action operation at a last point. The last point of code we are doing action operation, so that Spark will trigger our execution, because Spark is lazy. You know that I already explained you why the Spark is lazy, why Spark is follow lazy evaluation. You can check my video. So now I can print it for result, for records got in result is the variable records in result. Print it. It will try to print all those records we are getting as ascending order. Save it. Now to give a run. It will take me some time. It will take some time because my system is slow. Okay, it started executing. Executing. Now you see, for 58-year-old people we have a 1116 number of Tinder match. For 39 years old we have this. For 20 years old we are 165 match. Tinder match. Average average Tinder match of 20 years old people in my this data set is 165. Now if we scroll down. Now for 63 years old people we have a highest match. So for 63 year old, for 63 years old uh, old group people, we have a 384 number of average Tinder match connection. For 20 years old age group people, we have 350 number of average Tinder match. So that's how you are finding the average Tinder match connection from this data set. And here we are using some new concept, like, so I think I hope you already got this, how I am writing this thing. This is a very easy code. So if you are not understanding this thing, okay, how the index work, just take one normal data set, like just take this, and how you can do this, go to any file, then copy paste it, assigning this value in some variable, and try if you want to access this, how you can access this. Print x 0 1. If you print it, it will give 677. See, this is my tuple. Okay, I am getting this. Why I am getting this? For x, for y in x, and now if I do this for y, now if I run this, okay, assign you the variable sum y. Now if I execute this, print y, what we are getting this, we are getting this thing, getting this 48,677. And now if I try to y0, if I do this, we are getting 48. Now we want this 48 1 48 0. See 1, we are getting 1. This is because this is the from y we are getting a list of tuple of tuple. This is a tuple of tuple, and in the here we are getting one at the one index we are getting this tuple, okay, this tuple, and then I want to access this 677. Then I can write this like this, okay. Then I am getting 677. That's how you are. That's how you are. That if you don't not able to understand, that's how you can debug this code and try to understand what I am actually doing here, those index manipulation. That's how you should solve this question. And here I am using this reduce by key. You can use group by key also, but reduce by key is optimized. Why it is optimized, you can go through this article. I'll put this link in my description. Also I'll create one video about the group by key and reduce by key in a detailed manner. Wait for that video. Thanks for watching this video. In this video, that's it. In the next video, I'll cover Spark architecture. Okay, from the next video, I'll try to cover Spark architecture, those white narrow transformation, how, why, like what is the executor, what is the worker node, how resource manager is communicating with executor. Those things I'll do. Resource manager is communicating with the application master. How application master is requesting resource to resource manager. Those things I'll explain in next video. That's it in this video. Bye. Have a good day.